Now let's talk about erosion. When rock is broken into fragments, these pieces are moved from one place to another through the process of erosion. Water is one kind of erosion, and running water is the most effective force for changing and wearing down the Earth's surface. Pulled by the force of gravity, running water makes its way from higher altitudes to sea level, where oceans make up 70% of our planet's surface. Deriving energy from the sun, running water is part of the Earth's never-ending water cycle. Water that moves downhill from mountains and plateaus to large bodies of water, where it then evaporates into the atmosphere, before returning to Earth's surface as precipitation, and once again starting its downward course. When rain falls on mountains, it washes away pieces of rock and soil as it makes its way downhill. This downward action over many thousands and even millions of years smooths mountains into hills.
Often, when we see a river or large stream, the water appears muddy. What do you think causes this appearance? The water appears muddy because it contains soil, weathered rock, and other organic material. Fast running water can result in the loss of rich topsoil, leaving scenes of erosion like this. In some parts of the world, severe erosion has turned fertile land into arid waste, which eventually becomes desert. Practicing soil conservation, farmers and others can fight erosion by taking such steps as irrigation, rotating crops, and contour farming. The most dramatic valleys and canyons on Earth have been formed by the erosion of flowing rivers. Through mechanical weathering, rock fragments in the water grind down the bedrock of rivers, while the water, slightly acidic from exposure to the air, chemically softens the rock by dissolving some minerals.
The Grand Canyon, seen here from space, is our planet's largest gorge. More than a mile deep, it was carved out of rocks and soil over a period of 60 million years by the racing waters of the Colorado River. Rivers like the Colorado draw water from various other rivers and streams. Together, a river and its tributaries make up a river system. The area draining into a river is called its watershed, or drainage basin. Here, we see a map of the major river systems in the United States. Divides separate one river valley from another. Separating the western watershed from the eastern in the U.S. is the Great Continental Divide, which is located in the Rocky Mountains. The Mississippi River system has the largest drainage basin in the U.S. The Mississippi stretches nearly 2,500 miles before flowing into the Gulf of Mexico, where over time this powerful force of erosion has left a delta, or growing deposit of sediment and other debris, as shown in this Landsat radar photo from space. With such a huge river system, the Mississippi, like other rivers, periodically experiences flood conditions caused by heavy, sustained rain.
Engineers during the 20th century have struggled, not always successfully, to tame surging waterways through such river controls as dams, levees, and reforestation. In an avalanche like this, huge chunks of ice and snow break loose and tumble down a mountain to a lower altitude. Here, as in all other types of erosion, gravity is an important factor. In a similar way, rock slides occur when small and large blocks of rock break off a hill or mountain and cascade down. Pulled by the downward force of gravity, mudslides, like this after the 1980 eruption of Mount St. Helens, can destroy cars, homes, and almost anything in their path.
Huge moving bodies of ice called glaciers have over millions of years helped transform the Earth's surface. Glaciers form when snow builds up. Not melting and increasing in depth, the accumulating snow compacts into ice and then begins to slide forward. Glaciers start forming usually when snow reaches a depth of at least 150 feet. Moving yards, or sometimes only inches per year, glaciers, like this one in New Zealand photographed from space, can over time drastically change terrain. The largest glaciers are the huge sheets of ice, sometimes several miles thick, that are the continental glaciers covering Antarctica and Greenland. On a smaller scale, valley or alpine glaciers are found on the sides of many high mountains in various places on Earth. Advancing walls of ice, glaciers are like giant bulldozers, dragging material as they course forward and push everything out of their path. These deposits of material are called till. Dropped along the way or left in front of a glacier when it stops, tills are known as moraines.
Scientists tell us that for millions of years, Earth has periodically experienced ice ages. The last of these frigid periods ended about 10,000 years ago. During the last ice age, global temperature averaged only about 5 degrees lower than at present. But ice sheets extended south into the United States, Europe, and Russia. Most scientists believe our current interglacial, or comparatively warm period, will last thousands of years more. What do you think may have caused the last ice age on Earth?
Scientists are still not absolutely sure what has caused ice ages on Earth. However, many believe that temperature changes and the ensuing spread of glaciers may have resulted from changes in Earth's orbit and tilt. According to some scientists, these factors occur periodically, and in the past combined to alter the amount of summer sunlight in far northern latitudes, causing the greater formation of glaciers. Other scientists believe that Earth has experienced a gradual global warming during the last 50 years, and that this trend is resulting in glaciers that are receding and melting. They point to evidence such as these Landsat radar views from space. In the view here at the left, we see a glacier in Alaska more than 10 years ago, and at the right, a current view indicating that the glacier, instead of going forward, has retreated more than 5 miles.
The wind, like glaciers and rivers, is another cause of erosion. While wind is an agent of weathering, helping to break down material, it also can transport that material through the process of erosion. Through abrasion, the wind grinds away rock and surface material on such places as mountains and deserts. Then, through deflation, a geological term, loose particles are removed by the wind. So, the wind is an agent of change on Earth, both weathering and then eroding land, by creating and transporting loose sediment. Poor farm practices can create conditions for wind erosion. In America's Great Plains in the 1930s, for example, windstorms carried off topsoil from exposed dry farmland, which lacked vegetation. Here, we see a view from space of the U.S. Atlantic coastline. On Earth, coastlines of continents and other bodies of land are constantly changing as wind and waves and tidal currents erode shorelines. Usually produced by wind, waves pound coastlines, where rock is broken into fragments and sand is carried from one place to another. Coastal erosion has become a problem along parts of the U.S. Atlantic and Pacific coasts. With some shorelines seriously eroded by severe storms, houses have been destroyed and beaches washed away. In the face of heavy erosion, how do you think some dunes, like these, have been rescued?
Placing obstacles like old Christmas trees on a beach can help form sand dunes. When blowing sand hits the obstacle, it accumulates, and as more sand backs up, a dune is formed. Planting dune grass also helps to stabilize dunes. Wind and water can also alter shorelines by moving and depositing sand and pebbles in different places. Thus, different patterns of erosion occur along coastlines, resulting sometimes in sandbars with hooks, like that formed by Massachusetts' Cape Cod, as is evident in this photo from space.
To review briefly, during this program, we've discussed how the Earth's surface is continually altered.
First, through the process of mechanical weathering when rocks are broken into fragments.
And next, through the process of chemical weathering, when agents like air, water, and acid transform the chemical composition of rocks and minerals.
Then, we looked at erosion, where rocks and rock fragments are moved from one place to another by such means as water,
glaciers,
and the wind. In summary, we've seen how weathering and erosion result in constant changes on the surface of our planet.